Hey everyone, welcome to another episode of Learning Series where we break down the science behind rocket science. This week is going to be part 2 of our dynamics series, and we're going to be talking about dynamics of a rigid body. We have Papaya Tutors who is going to make it simple for us, so take it away.
Hi John! So for this learning series, we're actually going to have one of our other amazing Papaya Tutors explain dynamics of a rigid body. So go ahead, Roger.
Hello everyone, today we're going to talk about dynamic of a rigid body. So the first thing that we need to learn is what is a rigid body. An easy way to know what is a rigid body is that if we have 2 points of that rigid body and the distance between these 2 points never change, so that's a rigid body. Easy, right? Then we need to know what motions could has this rigid body. We have 3 types of motions: the pure rotation, pure translation, and the rotation and translation. Then also we need to know the second law of Newton. What is the second law of Newton? That the force equals mass times accelerations. But the other way to see this is that the force is the causes and the acceleration is the effect that the force causes. So always is going to be a relationship in the cause and the effect. Then a modern way to see this second law of Newton is that all the sums of the external forces is equal a rate of change of momentum linear over the time. So then, but what happens when the system of the rigid body is isolated? What means isolate? That all the sum of the external forces equals 0. So when that happens, the momentum is constant. So that's what explains when the rocket starts his motion. So because as we see in the picture, at the beginning of the motion we have the ball that is the fuel and we have the rocket. So at the start the velocity of the rocket is 0, but when they start the combustion the fuel has some velocity that goes to the other direction that should go the rocket. So then, as we know that the momentum is constant because in this system all the sum of the external forces are 0, so that means that whatever time or whatever is the position of these two, always the momentum is constant. So that means that when the fuel goes to the other way, then the rocket is going to be the opposite way. So that's the action and there's the reaction. So that's it. We make it papaya. So for the end, when I was learning dynamics, the hardest part was that I didn't know the difference between the particle and the rigid body. So for me, dynamics was easier when I find it. So that's my advice for you guys. So find the difference between particle and rigid body and you will note that dynamics is easier.